Let's do this question number 6 here using the derivative laws of inverse functions. Arcsecant is basically secant inverse 3x, and we learned the formula that derivative of secant inverse x is 1 by x times square root of x squared minus 1. Now in this question here, in place of x we have 3x, so that just say that we need to use chain rule after we apply. So 1 by, in place of x is 3x, square root of 3x square minus 1 times the derivative of 3x, that will be 3. So this 3 is going to be cancelled with this. We have our answer as 1 by x square root of 9x squared minus 1, using the derivative rule of secant inverse x. Let's look at this one. This has an exponential function e the power tangent inverse. Let me remind you guys the rule of the derivative of tangent inverse x is 1 by 1 plus x squared. Let's use that. Now, to find the derivative here, the mo of g function, the most outside function is exponential. And what was the rule of exponential function? The same as is. So the derivative of this would be this as is times the derivative of this function because of the chain rule. Let's write that down. E the power tangent inverse t square. Derivative of tangent inverse is 1 by 1 plus x square. So in place of x is t squares whole square times the derivative of t square. That is because of the chain rule. So what do we have? E the power tangent inverse t square times 1 by 1 plus t the power 4 times 2t. So that should be your final answer. I mean, you can max write it like okay. So using the new rules along with exponentials and chain rule. Let's look at this one. If you notice, this is product of two functions. Let's remind the rules which we're going to use in this. Derivative of cosecant inverse x is negative 1 by x times square root of x squared minus 1, and derivative of a the power x is a the power x times log of a. So these are the two formulas. Also, product rule, the derivative of u v would be first function's derivative times second function plus first function as is times the second function. So we're going to rule all these three rules here. Let's do this. The derivative of x times cosecant inverse 2x as is plus x times the derivative of cosecant inverse 2x. Okay, let's write down the things. Derivative of x is 1, so we do not even need to write this. This is just cosecant inverse of 2x. X times derivative of cosecant inverse, we're going to use this formula. 1 by 2 to the power x times 2 to the power x to the power 2 minus 1 times the derivative of inside the chain rule. Okay, cosecant inverse of 2x plus x by 2x square root of 2 to the power 2x minus 1 times derivative of this is using this 2x natural log of 2. and we can see that this can cancel with this. So our final answer is cosecant inverse 2x plus x natural log of 2 divided by square root of 2 to the power 2x minus 1. Let's practice one more inverse functions derivative problem. We have arctangent. You guys know that arctangent is tangent inverse square root of 1 minus x by 1 plus x. And the formula which we're going to use, the derivative of tangent inverse x is 1 by 1 plus x squared. Okay, let's use that. So we need to find dy by dx, that's the derivative. Most outside function is tangent, so we're going to apply that. Derivative of tangent is 1 by square of whatever is inside, 1 minus x by 1 plus x, times the derivative of this. Okay, this here, square and square root cancel. This is just basically this times this thing here is derivative of this, but this I'm gonna change it and can be written as this. Actually, square root can be written as power half. So what is the power rule? Half comes front times 1 minus x by 1 plus x is power half minus 1 times the derivative of 1 minus x by 1 plus x. So we are applying repeated chain rule. Also, we need to simplify this. So common denominator here should be made using that. For this part, this is 1 plus x. 1 plus x would be multiplied here plus 1 minus x times half. This here should be half minus 1 power, which is negative half. So this will be flipping. Okay. So square root of 1 plus x by 1 minus halves. How did that happen? Why did it flip? Because the power was a negative power. Okay. Times. For this part, we need to use the quotient rule. The derivative of a quotient is quotient square, derivative of the numerator times derivative denominator as is minus u times derivative of the denominator. So let's use that. 1 plus x whole square. Derivative of the numerator is negative 1 times the denominator as is minus numerator as is times the derivative of denominator. Okay, let's see. This here will come up front and this x cot cancels. Let's see what we have. 1 plus x here by 2 times 1 by 2. 1 plus x here. 1 minus x here. 1 plus x whole square minus 1. Then this multiplies with this multiplies with this, minus x, minus 1 plus x. Okay, let's see what all can cancel. This cancels. This with 1 power of this will cancel. So we have, and I zoom out a little so I have more space. So what do we have left? This is negative 1 plus negative 1 will be negative 2. 2 times 2 is 4. This here is square root and this is just 1 power. So this will be cancelled. Only 1 power of Square root 1 plus x is left, and square root of 1 minus x is already there. So this is all I have. This will cancel 2. We will have negative 1 by 2. And a minus b times a plus b can be written as square root of 1 minus x squared. That should be your answer. So see, this question was long and a little more complicated, but the thing is that we are just using the tangent inverse formula, and then the square root is done using the power rule, and inside there was another quotient, so we had to apply the quotient rule also. So all rules are just being applied together here.